So, the best part about today's lesson? You already know how to do it, okay? What are we doing today, by the way? We are finding the inverse of a cube function, okay? So if we look at a function like this, y equals x cubed plus 5, how do I find the inverse of that? Well, the first step is always the same, isn't it? What is the first step? Good. If I switch x and y, I get x equals y cubed plus 5. What do I have to do now? Isolate y. Solve for y. Okay? How do I solve for y in this situation? First, I subtract 5. Absolutely right. X minus 5 equals y cubed. Is y isolated? No, that's correct. Okay? Now, a lot of people think y is isolated because y is by itself, right? But it's not. It has a cube with it. In order to completely isolate y, it just has to be y, nothing else. How do I get rid of that? Because what is the inverse operation of cubing? Cube rooting. Okay? So I'm going to take the cube root of both sides. Can I simplify this side any further? No. So I get cube root of x minus 5. Can I simplify this side any further? Well, I hope so. That's why I took the cube root of it, right? That gives me y. Any questions? Because we're done. That's it. Okay? Let me show you another example. Y equals the cube root of x minus 4. What do you think we ought to do first to find the inverse? Good. Switch x and y. When I switch x and y, I get x equals the cube root of y minus 4. What would you like to do first? Can we add 4 first? No, because the 4 is under the radical. So what do I have to do first? Absolutely, I have to cube it first. I'm going to cube this whole thing. I'm going to cube this whole thing. What do I end up with on the left-hand side of the equation? X cubed. What do I end up with on the right-hand side of the equation? Good. Y minus 4. Is the y isolated? What do I have to do to isolate it? Very good. Add 4. So x cubed plus 4 equals y. And you're done. That's exactly right. Okay? Now, when we talked about inverses before, we said to find an inverse function, you switch x and y and solve for y. We've done that, right? I gave you 2 separate examples for that. The other thing that we did when we talked about inverse functions is I gave you 2 functions, like f of x equals, let's see, the cube root of 2x plus 5, and g of x equals x cubed minus 5. Right? I gave you 2 functions and then asked for what? Do you remember? Yeah, I ask you, are they inverses, right? Are they inverse? Or sometimes the direction said, verify that they're inverses, or state if they're inverses. All that stuff being said, you figured out if they were inverses, exactly like you said. You said f of g of x. Do you remember doing that? And then g of f of x. Now, just as a reminder, I'll write it out here in the margin. There's 2 ways that it can look, right? It can look like this, f of g of x, or it can look like this. But remember, those 2 mean the same. Okay? Fog because it looks like it says fog. Not because we're actually talking about fog. My main concern in these things right here is on the previous test when we first talked about inverses. A lot of you did f of g and then you multiplied it by x. Guys, is that what this is saying? Is this saying find f of g and then multiply it by x? Absolutely not. It's saying f of g of x. We're talking about a function that we're using x as our variable. This is just like a placeholder for our variable. Okay? I'm not multiplying f times x. I'm saying f of x, a function using x as the variable. Okay? So how do I figure out if these are inverses of each other? Well, I do f of g of x and then possibly g of f of x. So let's start with f of g of x here. Okay? If I start with f of g of x, I'm going to start with f. I'm going to write f, except anywhere there's an x, what am I going to put in there? G of x. So I'm going to write the cube root of 2 times g of x plus 5. Now, do I know g of x? Yes, I know g of x. The cube root of 2 times x cubed minus 5 plus 5 equals, what do I do inside? Distribute. The cube root of 2x cubed minus 10 plus 5. Can I simplify that any further? To what? Cube root of 2x cubed minus 5. Do you guys know the cube root of 2x cubed minus 5? Me neither. So that is as far as I can go right there. So what does that mean? If I do f of g of x and I get this as my answer, what does it mean? What do I want to get right here? Good guess. What do I want to get right here when I do f of g of x? I want to get x, don't I? Did I get x? So what does that mean? They're not inverses. Okay? Earlier, someone said, well, I have to get the same thing. And while that's true, like if I do f of g of x and g of f of x, don't I have to get the same thing? Yes, I do, but that same thing both has to be what? X. Okay? Guys, why does it have to be x? Remember for me. Why does it have to both equal x? God bless you. What do inverse functions reflect across? What line do inverse functions reflect across? Y equals x. That's absolutely right. Okay? Because that's the line they reflect across, when I substitute one into the other, I want to get that line. I want to get y equals x. Okay? So at this point in the problem, if these were my two functions and this is the point we are in the problem, what do I do? Do I go do g of f of x? No, I don't have to, because this is, I already know, is not x. So what do? I have to do something to make myself remember and to help me know that you just didn't quit. What do I write? Does that make sense? To anyone? 3 people. Excellent. Okay. What would I do if I did all this work and I got equals x? Would I write yes inverses? Or would I have to go do g of f of x? Yeah, that's exactly right. I'd have to go do g of f of x. And then when I did that, I would have to get it equal to x. And if both of them are equal to x, I get yes inverses. Okay? Now, the reason I did this one the way that I did is because the last examples that we did, every single time it said verify that these are inverses, or show that they're inverses, or determine whether they're inverses, they always all were. Okay? You always got x both times. So I wanted to show you what it might look like if you got something that was not an inverse. Okay? Do you have any questions about this? Are you feeling confident about this? All right.